We just got through the keynote for React Conf, and I had to run up to my hotel room so we could quickly talk about it because it was really, really cool. I think there's a lot here to dig into, and I want to take the time to do it as quickly as possible. So without further ado, let's talk all about the big things that just shipped in React. The first half was focused on React 19, which if you want to know more about, you can go check out my video that I already posted about it. It's a long deep dive on all the cool things React 19 is changing. The big one that got the most attention for sure was the removal of forward ref in favor of passing refs. The crowd went nuts. The one big thing that got announced around React 19 is the fact that it is now an RC, and the React 19 stable version should be shipping within the next couple weeks. I'm super hyped about that. React 19 is not the reason I rushed up to make this video though, because as I said, I already have one. I'm here because another big announcement was dropped. React Compiler. Remember React Forget at the last React Conf? We've been waiting for almost 3 years now for an update, and boy, did we get one. React Compiler just went open source. And when I say just went open source, I mean I was bugging the team to open source it so we could quickly read through the code before doing this video, because I think it's important to understand what this thing is and how it works. That said, turns out it was 1,900 commits, like 1900 commits, and over 300,000 lines of code, including both a JavaScript version and even a Rust version that's still in progress. So there's a lot to dig into here. I want to take the time to do it, so let's get cooking. Before we look at the code, I think it's important to understand a little bit of what React Compiler is and it's trying to do. If you've worked with React, you've had an experience before where something would update and it would trigger a bunch of things you didn't expect to update, and the result is the website feels really slow, sluggish, and just not great to use. This is one of those common tropes in React that's gone as far as people making whole new frameworks trying to fight it. Obviously, signals are blowing up too. People are really hyped about these new solutions. The React team went a different direction. They wanted to try and keep React code as elegant as possible, the React code that we always see in demos, without all of the memoization junk that we had to do in order to make it performant. They gave a bunch of examples of how painful it is to memoize, which is funny if you think about it, that the primitives that the React team made are being made fun of now by the React team. But I totally get it. Doing this stuff right sucked. It sucked hard, which is why they're rethinking this whole thing from scratch, and I'm so thankful they're doing that. The results speak for themselves. The numbers they dropped are crazy. For a few months now, all of Instagram.com has been using React Compiler as a part of their build process. And even though this is Instagram.com, you know, by the company that makes React, despite the fact that they had already optimized the code pretty well, they still saw a 2.5x improvement in the responsiveness of the app for certain interactions, and a significant improvement in the time to load pages as well. And we're not even talking about the code savings. They were able to remove up to 17% of the code from some of the more memoized components, and they haven't went through and stripped it all yet, which is another important detail. If you're already using Memo and using all these fancy optimizations in your app right now, you can leave them in. You don't have to delete them. The same way you didn't have to delete your class components to use hooks, you don't have to delete your use memos to use the React compiler. But this gets a lot more interesting as we dive into the details, so I think it's time to do that. The React Compiler docs, finally out. So crazy to see this on the React site, by the way. If you want to get to this quickly, they have a short URL, facebook.me/react-compiler. This is the link. They also just merged the PR, and getting through this is going to be fun. Even just opening the Files Change tab is enough to cause GitHub to lag immensely. So we're doing some research. We're going to have a lot to talk about with the source code in the near future, but for now, this is meant to be an overview of what this is and how we benefit. So let's take a quick look here. React Compiler is a new experimental compiler that we've open sourced to get early feedback from the community. It is a build time only tool that automatically optimizes your React app. I want to emphasize how big of a change this is for the React team. React has never really thought about build tools too much. Obviously, they've made integrations for them so things will work, but historically, React has just been the runtime. With server components, they move to the server, but with this, they're moving to build. That said, the benefit here isn't just in the build. It's actually not in the build at all. Your builds might be slower because this is a Babel plugin. The benefit comes in on the client side, because now your apps are going to behave so much faster, and the code you write to make it that fast is going to be even simpler. It's a really cool change and a nice alternative to the other solutions we've been seeing with things like signals. It works with plain JavaScript and understands the rules of React, so you don't need to rewrite any code to use it. The rules of React thing is going to be coming up a lot, so make sure you're noting that. The compiler also includes an ESLint plugin that surfaces the analysis from the compiler right in your editor. The plugin runs independently of the compiler and can be used even if you aren't using the compiler in your app. We recommend all React developers to use this ESLint plugin to help improve the quality of your code base. This was an interesting thing I learned from talking with the React core team. They ended up, as a company at Meta, getting better at the rules of React because of React compiler. Despite the fact that this is the company that made React, there were still plenty of places where they weren't fully following React's rules, and in order for the compiler to work its magic, it expects you to follow those rules well, and it will ignore files where it doesn't see those rules being followed properly. This ESLint plugin is like the rules of hooks plugin plus plus. It's like a pushed up and stricter version, but I think it's going to help all of us write better React code anyways, and I'm excited to see how it behaves in stuff like this, and also how well we can optimize our code. So what does the compiler do? The compiler understands your code at a deep level through its understanding of plain JS semantics as well as the rules of React. One thing it doesn't do is go between files though. The React compiler is focused on the file itself and the contents of it, so it can't optimize things that are over file boundaries. Turns out you don't need to do that in order to have crazy performance wins, but I thought it was an interesting detail. You may be familiar today with manual memoization using useMemo, useCallback, and React.memo. The compiler can automatically do this for you if your code follows the rules of React. If it detects breakage of the rules, it will automatically skip over just those components or hooks and continue safely compiling other code. Again, huge. Makes starting to adopt this significantly easier. And unlike a lot of the recent things React has shipped, like specifically server components, this is something that most of us can throw into our apps and see a benefit from already, which is so cool. To be clear, might not be ready for production usage yet, although they're using it in production already, even in React Native apps like the Oculus store for the, Quest store for the VR headset. So they're using this for React Native and React Web, and obviously the React Conf app too. It doesn't mean it's ready for everyone to use in production, but it does mean it works, which is really exciting stuff. Speaking of which, should you try out the compiler? Please note the compiler is still experimental and has many rough edges. While it has been used in production at companies like Meta, rolling the compiler out to production for your app will depend on the health of your codebase and how well you're following the React rules. You don't have to rush into using the compiler now. It's okay to wait until it reaches a stable release before adopting it. However, we do appreciate trying it out in smaller experiments in your apps so that you can provide feedback to us to help make the compiler better. Really cool stuff. Here's a bit of info on that Rust port. We have a work-in-progress Rust port of React compiler. The code here is unused. It was developed to help understand the feasibility and path to porting to Rust and integrating with various Rust or non-JS build systems, such as SWC, OXC, ESBuild, etc. We are currently in the process of changing the data representation used in parts of the compiler to both improve compilation, which will also have the benefit of making it even easier to port to Rust. We'll reevaluate where to go with the Rust port once the refactoring is complete. Cool to see that they're already considering faster solutions. There's no promise any of this will ever ship, but they're not just waiting for a future where they might rewrite it in Rust. They're making sure that this path exists from day one. Personally, I think something like Golang might have made a bit more sense here, just in terms of how much easier it would be to contribute to and how much faster they could get a working version. But Rust would be the ultimate in terms of performance. It's cool to see that they're considering these things day one, because making a jank JavaScript Babel plugin to be this important a dependency is going to be a huge change. Especially if you're trying to use this in dev to make sure the behavior is exactly the same in both production and in dev. I have concerns that the build times in dev are going to get a lot longer here. I'll be sure to play with that in just a second, actually. Let's give that a shot. Okay, turns out this is a little harder to set up than I thought. I missed a bunch of things, including but not limited to forgetting to install the Babel plugin, installing the ESLint plugin thinking it's the Babel plugin when it isn't, installing or using 18.3 version of React, which is not the right version for this, and then even when I updated React, forgetting to update React DOM, which threw some very strange unexpected errors. Anyways, all of that is handled. I now have an environment in Vite that can use the React compiler. You might notice I have it commented out because I want to showcase how this works right now. Here I have a function, block sync, that blocks synchronously for 2 seconds. This is meant to simulate a slow component. Obviously, this should be async, but this is meant to show what it looks like if you have a component that happens to be really slow. Let's say it's a component that has a ton of other components that it's mounting. I have slow component, which blocks for 2 seconds, and then it returns the div, this component is slow. Here I have the count, set count, the usual super simple demo. I have the images here, yada yada. But I have our button here where we set count and also have the count component. And we also have slow component here. Because of that, every time this component re-renders, it has to re-render slow component to make sure nothing has changed. And because of that, this is going to take a lot of time when you click the button. So when I click count, we're waiting, we're waiting, we're waiting. We're actually waiting for up to 4 seconds because it's rendering it twice to double check in dev mode. And even if I click again, same deal, waiting, waiting, waiting. And then we see count is 2. Normally, we would memoize this component. I can show you what that would look like if you really want to see. Const memo slow equals react.memo slow component. Cool, we have to import React. And I can swap this over to memo slow, refresh the page. Technically shouldn't have to refresh because hot reloading is cool and all, but I'm doing it just to make sure everything is fine. This component is slow, count 0. Click it, and now this loads immediately because this is no longer blocking. The magic is not having to do this though. So I'm going to comment this, or actually, before I show you that, I'm going to show you what the actual source code looks like once this is output. So we hop into sources. When you're in the sources, you have the source maps. This is like the actual code. But what we care about here is the code that is being used. So here's the code that's actually generated here. And we have all these little indicators like pure, whatnot. I have the memo call, the little comments being inserted by the compiler here to make things slightly easier for it. But this isn't the React compiler yet. This is just standard build stuff and then turning JSX into JavaScript code. But nothing here should stand out as particularly exceptional. This is just mounting components and doing things the normal way. It's like a jankier version of React code. We have like the hot reloading stuff built in here. We have all the imports for all the assets and things. But this is pretty boring code, and it's calling things the way you would expect. Like the useState call is done directly here. Nothing super special. This is where things get interesting though. I'm gonna comment that out. I'm gonna switch this back to slow component. So now it's going to be slow again, but I'm going to uncomment the Babel plugin React compiler. Now I'm going to refresh the page to make sure everything's in a fresh state. Wait for the page to finish, and now I'm going to click the button. And it's still fast even without the memoization. I want to look at the code though, because this is where things get really interesting. So again, we have the app TSX, the actual code with source maps, but here's the real generated output. So this is the part we are interested in. And you see in here, things look a little bit different. We have this const $sign equals underscore C2. Obviously, this isn't jQuery. Crazy, I know. This is their syntax for memoizing things internally. This is crazy nonsense you should never have to look at, but the compiler is effectively generating a bunch of references inside of the components in order to handle these things for you. So all of this stuff is built in here. It can handle memoization if you pass it props, etc. And then an app, similar utter chaos going on here. We still have the useState call, but above it, we're having all of these React memo cache sentinel things happening first. And then down here, we see this crazy additional check where we reference the second value, index 1 of the $sign array, in order to see if this is a symbol for the cache entity, which means do we have a cache entity for the thing we want to do right now? If so, we can yank things from that cache to render them. Otherwise, we don't. So this is effectively caching the render state so it can pull from it directly. We have a couple additional lets here. You'll see a lot of let going on in this because we're assigning values through the render and we're pulling from a cache when we can, instead of having to rely on our own memoization to do that caching. Effectively, every single variable you're defining is getting put in a cache so it can reference and check if it can pull from that basically always, which is almost always going to be faster than recalculating the value. So checking for all of the different values that exist here to see if they exist yet or not, even pulling things out of the JSX and seeing if these can be made pure and cached or not. But of course, when you make this change and you have, as you see here, significantly more code, optimizing to make sure that these states aren't being re-rendered for no reason is now trivial. Obviously, this was not easy for them to implement, but the results, really cool. One more thing I wanted to try quick though is to see how the performance has changed in dev mode. So specifically, when I make a change here, how long does it take to see it in the browser? How much is Babel slowing us down? So we'll do something simple, which is just delete this paragraph at the bottom. I am saving in just a second. You'll see the little thing in the corner there change from the dot to not a dot when I save. So let's see how long it takes. Still pretty snappy, all things considered. When it already has it in the cache for the build and doesn't have to check to make sure there's something different with the build. So like right there where I had two different states that it's already compiled, it can pull from the cache for that. But I make a new state by adding a new div, hi, and save now. That's still really snappy. You know what? Maybe my concerns aren't justified. Obviously, this is a really small component in a really small demo app, but I would have expected to see a much more significant build time penalty by running things through Babel. It's technically only running this one file, so it's not too big a deal. That said, I was expecting much worse here. So I'm pretty pumped. I obviously have limited time to go through all of this. As much as I would love to dig into it more, I will obviously be doing that in the future. If you want to see how these things work and play with them now, you can go play with the React compiler playground, which will show you these outputs. But I have another recommendation that I think is really good. Jack Harrington actually got early access to the compiler, which I'm hyped about because he was able to do a really cool video breaking down how it works and what the value is of it. But it mainly is meant to showcase different examples and use cases where compiler makes things better, sometimes even makes them worse. Definitely check out his video if you want a deep dive on what this looks like to use, and make sure you subscribe to the channel here if you're not already in order to keep up with how these things change over time and what people are actually doing with it. I'm really hyped about React compiler. This is a huge change and a fundamental shift in how we think about writing React and other web applications. I couldn't be more hyped to play with this. Let me know what you guys think in the comments because I think the future is very, very exciting. Until next time, peace nerds.